Okay, welcome to my final project presentation. I will be talking about construction in low-gravity environments and what it will take to build a settlement on Mars. Because of my background in design, I also really wanted to include some rough concepts I drew up for this project for what I think the structure might look like. My main goal in creating this project was to do research and really gain an understanding of what goes into settlement proposals for life on Mars or the Moon. Starting off looking at the floor plan I sketched out, we can see there are individual living spaces for each resident, as well as a large common room. I have also included ample space for storage and technology to maintain the base. This structure was designed to comfortably house 4 residents at a time. I also created a very rough render of what this structure would look like on the outside. The edges are all rounded, and I included windows and skylights to incorporate some home comforts for the colonists. Now that I've shown the images I've had in my head for the last few weeks, let's move on to the basic challenges Mars presents in terms of construction. So Mars is fairly similar to Earth in terms of chemical makeup, but it's a planet not suitable for life on its own. It will take some working around to even begin life here. For one, Mars's atmosphere is virtually non-existent. Without a sufficient atmosphere, our colony is subject to dangers from radiation and cruelly cold temperatures averaging minus 80 degrees Fahrenheit. Mars only has about 38% of the gravity Earth does. This may seem harmless, but it will take a lot of adapting when it comes to construction, since it's a very weight-reliant process. And the last major factor I have listed here is the dust on Mars' surface. Not only is it a danger to inhale, but dust storms are frequent on Mars, and building on unstable ground like that could absolutely ruin a colony. I'm not saying all of these things to say life on Mars is impossible, but it's important to consider these challenges because we can only accomplish a Martian colony if we work around these difficulties. When I was designing this structure, I considered 3 major aspects of its design: shape, materials, and the quality of life it could provide its residents. Cylindrical shapes are fairly popular in the world of Martian building proposals, and there are a few reasons for this. For one, rounding the tops of standard building plans keeps the same space while drastically cutting down on materials used, something we will need to take full advantage of on Mars. Also, these kinds of shapes work really well in funneling wind around buildings and decreasing likelihood of damage. Next, we have to consider what materials would be best for a structure like this. Should we use the most durable available to us like steel, or something easy to transport like bamboo? Also, what is already readily available on Mars for us to use? And finally, I evaluated quality of life when designing the structure. Is there sufficient space in the building, separate living space for the residents? Will this even be remotely comparable to the quality of life they are used to on Earth? These are all some big things I had to consider when working out the details of my settlement. Let's expand on the material category. What makes a good material for Martian construction? Well, transportation is one of the biggest hurdles. We need something lightweight and small to even consider transport from Earth. We also need a material that is sustainable and fast-growing to meet the demands of Martian life. And finally, we need durable and versatile materials that can stand up to new challenges. Looking at all of this, there is one contender that stands above the rest, and that is bamboo. Seeds are very easy to transport. Bamboo is one of the fastest growing plants in the world, and it's a very hardy plant that has dozens of uses beyond construction. Bamboo, used in conjunction with materials already found on Mars, will serve the colony well. Now let's talk about the physical process of construction. There are 2 ways to approach building on Mars, and it will almost surely take a little bit of both to succeed. There have been some recent plans floating around to use large 3D printers to assemble buildings from a concrete mix of Martian soil. This would most likely be implemented long before a human mission is sent. Once the base is well started, humans can begin being sent there to live and finish construction with a hands-on approach. This comes with its own challenges, as it will take a lot of adapting to be able to build in such low gravity conditions, but it can be done. Moving on to the interior of the structure, I had plans for the aesthetic elements as well as the practical elements available to residents. My goals for the aesthetic side of things was to primarily increase that quality of life I talked about and provide a home for the colony, not just a base. The theme was sleek and modern designs with organic touches, save for furniture and accessories. I wanted to include plenty of plant life as well. On the technical side of things, I left space for all technology needed to safely run the base, as well as storage and essential living space. Here, I have attached a borrowed image as an approximation of what I expect the interior aesthetics to resemble, a nice mix of practical and homey. Really drilling into that quality of life, I pushed it even farther and included the possibility of allocating extra construction for things like indoor walking paths and mini parks, where there was plenty of plant life to enjoy. Though I didn't include it in my original sketches, I think this aspect is very important for resident life. So wrapping things up, I think through all of the research and time I put into this project, I was really able to gain a new appreciation for art created by designers working in conjunction with brilliant scientists. I got some insight into what really goes into building proposals, and I pushed myself out of my comfort zone.